All right, so we're going to go over the practice final. Hopefully this helps answer some of your questions. And you guys have already read it, I'm assuming. So the first question is all about a piston, and we're being able to measure pressure and volume and temperature, which is no surprise. Now, the original question did ask you to draw a graph, and I took that out because you couldn't draw a graph. But if I was doing this as a student, I would definitely draw the graph so that I could figure out what was going on. And so I noticed that it decreases in volumes. That means the graph has to go that direction to begin with, right? And it stays at a constant pressure. So it would definitely even look like that. So that'd be A to B. And then it says in process B to C, it expands, so it's going to go that way, to its original volume. So it's got to end up back over here at C. And I know it's isothermal, so it's going to be like concave, like that. And then, oops, now I've covered this up. And then it says it returns to its original state without any work being done. So I know that's going to be straight up. So I know it's going to look something like that. So we're going A to B to C. So it didn't ask me to draw it. The original question did, but it just is helpful for answering the questions. So let me point out some of the mistakes that I noticed as you guys were doing this. So it says in the process B to C. So let me do this as a highlighter. B to C would be this section, right? So from B to C, I know that it expands, right? And I know it's isothermal, but you have to tell me what those things mean, right? So a few of you said isothermal means energy stays the same, but it's not energy, it's delta U. It's your internal energy, because you have to have a specific. So that you can't just say energy, right? And some of you said energy. So you had to first state to get one of the points that isothermal means delta U is 0, right? There's no change in temperature. You could have said that, but you still have to state that the internal energy stays the same. It expands. So you had to say that that meant that there was negative work done on the gas, or in some way stated that. It didn't have to be in those terms because you know how we can define work differently, but somehow that the gas was being compressed, so somebody's doing work on it. I don't know, something like that. You did need to state the law. Delta U equals W plus delta Q. You can't just magically say, some of you just decided to say that, oh, because U is 0, negative W, right? A few of you said negative W, I meant to make that this, negative W equals Q, but that is not a given law. And so you needed to start with the delta U equals delta Q plus W, and because that's 0, now you can say this, right? But you couldn't just jump there. So that was another point. And then you got another point for saying heat is added. So that's where the 4 points came from that first part. Okay, so let's erase that. I'm going to leave the graph. Okay, it's not going to let me erase the W. Fine. But at least I get rid of most of it. Interesting. All right, I got rid of some of it. So then the next part says, for process C to A, so again, let's highlight that. Maybe we'll highlight that green. So now we're here at C, process C to A. We're trying to figure out which way energy flows. Again, you can't say energy. I mean, a lot of you are using energy in terms of temperature. Energy is not temperature. That's super important, right? That became very evident. That change in energy doesn't have anything to do with that. No, no, no. You got to use your laws. The answer was, for one point, that the net flow of energy went into the gas. You had to say something about work was equal to, that's an eraser. That doesn't work. You had to say something about work was 0 because there's no change in volume. It says that, what was the phrase they said, without any work being done on it. So somehow you have to state that. I mean, it could be you apply it because it says it was stated, but somewhere in it you had to understand that the work was 0 since there's no work done on it. The temperature has to increase because you have to realize that from here to here, if this is T2 and this is T2 because it was isothermal, this was T1. And You could have used the ideal gas law, Pivner. I don't care how you wanted to get there, but somehow you had to explain that T had to increase. And then again, using the second law as we had down here, you had to then state that delta U would be equal to Q since there's no work. And so since U is positive, Q is positive. Some people's, again, there were different ways to get there, but that was the gist of it. So that was 4 points for that. And then the next part, you had to say how you could do that. A lot of you, it was supposed to be a constant volume. So a lot of you said to hold a plunger still, but when I read the answer sheet, the only thing that they really made sure is that somehow you're adding heat, so you could do it by putting some sort of heat on it, right? Bunsen burner, hot plate, hot water bath, any of those. Now, a lot of you missed the boat on this one. This is at a higher temperature. And this is at a lower temperature, and I see that because of where the peaks are, right? Did I just say that? No, I said it right. Huh. Good. No, I said it backwards. Oh, I did. See, I did exactly what you guys did. Let's try again. You're all going, Ms. Davis, no. It's where the peak is, right? The higher the speed, the higher the temperature. So this one's at a higher temperature, and this one's at a lower temperature. I think I said it right this time. And so we know that, remember my PV graph went like this, right? And this was A, and this was B, and this was C. And we know this is at a higher temperature, and these are at the same temperature. So this is temperature 1, this is temperature 2. So you had to say that B and C were this one, right? This is B and C, and this one represents state A. I had a lot of you talking about changes of state. That is not what it said. Okay, a change in state is, or process is when it goes from A to B. A state is A. I'm at state A, I'm at state B, I'm at state C. Obviously, I've missed the boat because there was a lot of you who missed that, and I was surprised. So a state is, so the concept with thermodynamics is that a gas at any given state, of state A, it has some P, V, and T, and it doesn't matter how it gets there, right? It's always, once it gets back there, it's at the same P, V, and T. That's the concept of state. Doesn't matter how you get there. So sorry, that must have been my fault because a lot of you missed that. And I want to make sure that was clear. All right. And that was 3 points, right? You had to, so some of you talked about the speed and the peak, so you got 1 point for that. A few of you talked about PVT. Somehow you had to explain to me why A was at a higher temperature. And then you had to say both C and or B. Some of you just skipped it and just said, oh, I'm just going to talk about one state or the other. But obviously it could represent either one. Right? These are, it's obviously not, doesn't have to be both B and C, but it could be B or C. All right? That's what the key one. All right, so let's erase what I can. I don't know what it'll let me, oh, look, it's letting me erase all of it this time. Yay. So let's erase all this. And let's go to the next part. So this is where we have a particle. It's got a positive charge. It's coming into a region. Again, you didn't have a lot of time, so a lot of people, some people did awesome on this one, and some people were like, I think they just ran out of time, or you don't like dealing with fields, but I tell you, fields is going to be on there no matter what. So the figure above shows a particle with a positive charge Q traveling the constant speed. It's going to the right. And then unfortunately, next page. The dash box represents, so we have the dash box like this, and here's my positive Q coming in like this, so we have the picture again. It says, describe in detail a possible path particle if the region contains an electric field pointing towards the bottom. So you had to know that E was pointing in that direction, so then there's going to be a force going in that direction, so it's going to curve down. Now, I was looking for parabolic, but I took any phrase that kind of meant that, as long as you said downward. Some people said it would curve downwards and end up exiting at the bottom or something like that. It was a little fuzzy if you just said it went down, so you did have to say something about it would exit at the bottom and not keep going in a circle, as opposed to Describe in detail a possible path of a particle in the region if the region contains a magnetic field pointing out of the page. So you had to use the right-hand rule, and if you use the right-hand rule with your thumb going to the right and the B field coming out of the page, the force is still going to come down. The difference is that now it's going to go like this, right, in a circle, but it's still going to be going downwards. So something about circular and downwards. Some people said things about perpendicular to the direction it's traveling. Would get stuck in the field. Those were key phrases, but you couldn't just say down for either one. You had to have a little bit more than that to get full points for that. And then what is the main difference between these paths? And that's where I was trying to get from you guys. Well, I wasn't, the question was, is that E fields are always pointing in the same direction. So it's always pointing down. And so it was parabolic, and B fields always perpendicular. So it's always circular. So somehow, some way you had to get that across to me to get the 2 points. And then which one's the closest to being like gravity? And it's an E field, there was no other choice, and you just have to say because it's always pointing down just like gravity, or the force doesn't depend on the direction of the object, that kind of thing. All right. And then we got to this one where you've got this proton beam with different protons at different speeds. So you had to realize that they had different speeds, right? So it could be V1, V2. And you had to figure out why some would exit at 1 and some would exit at 2. So there are some key things that they were looking for. You had to say that there were 2 forces. Somewhere on here it says, see, and again, initially there's these 2 forces and they're acting opposite of each other, right? Because the E field is going to push it up, right? So FE is going up and FB is going down. Something about, you had to prove to me that the magnetic force was affected by speed. That could simply be saying that FB is equal to QVB, but an electric field is not, so E is equal to FQ or something like that, but it didn't matter. There's no V in it, so that was important to get that point. You had to say something about you had to add the forces, that there were 2 forces on it. Somehow you had to say that. And so therefore, if they were going faster, right, then they'd have more of a B field on them. Do I have that backwards on there? Oh, yeah, no, I have it right. Would be at exit at point 2. I think, yeah, if they were faster, they have more of a, they'd go down faster, right? And if they were going slower, then the E field would be stronger, right, and would push it up to 1. So that was 5 points, and I had people get 0 points on this. So hopefully that helps. There you go.